This video is on the trends in acidity. It can all be summed up in one statement. Acidity depends on the stability of the conjugate base. If you apply this statement to any question regarding acidity, you are most likely to get the answer correct. What do we mean by it? Well, the more stable the conjugate base, the more acidic a molecule is. If we think about how an acid works, this makes sense. By definition, an acid is a proton donor. Therefore, the easier it is for it to donate the proton, the more acidic it is. So if an acid donates a proton, it forms a conjugate base. This is inherently an unstable ion, but the more stable it is, the more likely it is to donate that proton. Inversely, the less stable it is, the stronger a base it is, and more likely to snatch back the proton to reform the original acid. Of course, it's not just that simple, because now we need to understand what things affect the stability of the conjugate base. The first thing to look at are the electronegativity and size of the atom the proton is bonded to. As you move along a period, the electronegativity tends to increase. As the electronegativity increases, the acidity increases. This becomes clear if we look at the stability of the conjugate bases. As you have a more electronegative atom, it is more stable as an anion because it wants that negative charge, it wants those electrons. Whilst something that is not very electronegative is going to be very unstable as an anion, and therefore the conjugate base is unstable. The acidity also increases when you go down a group. This is due to the size of the atom bonded to the proton. As atoms get bigger, the orbital overlap with the proton decreases, so you're forming weaker bonds. The easier it is to break the bond, the more acidic your compound is. Furthermore, as an atom becomes bigger, it becomes more stable in a charged state because the negative charge is more dispersed. These trends can clearly be seen if we look at the halogens. As we move down the group and the ionic radii of the halogens increases, we notice that the acidity also increases. Note that this goes in the opposite direction of the electronegativity trend. So you might be thinking, well, how are we supposed to know? Well, rule of thumb is size is more important than the electronegativity. More specifically, if you are comparing atoms in the same period, electronegativity is more important, whilst if you're comparing atoms in the same group, size is more important. But of course, these are general trends, and the more you look into them, the more flaws you see in them. So let's just not worry about it and assume that any question that comes up will be pretty specific or obvious. Speaking of which, here are two practice problems. Which one of the following two acids is more acidic? You may pause now, and here are the answers. We'll continue that with an extra question. Which one of these two is a stronger base? You may pause now, and here's the answer.